Righto, let's have a look at this preliminary chemistry exam. We'll just do the multiple choice section first. Year 11, right, let's go. So we're told here delta S is plus 22 joules per mole. Okay, is it spontaneous? Is it a spontaneous process? Endothermic? If it's spontaneous, that would be delta G. Endothermic, we need to know delta H. Entropy is disorder, is delta S. And whether it's exothermic or endothermic is delta H. So which one is delta S? That is C. Okay, so let's have a look here. We've shown an electric field and three possible particles. Electrons are negative, so negatives and positives attract. That's correct. Neutrons are neutral, has no effect. Protons are positive, and that should be going the other way. So that is wrong. So what's correct? 1 and 2 are correct. Okie dokes. So we're showing some pipettes here. How do you measure a pipette? Well, you go from the bottom of the meniscus, which is this one here. Okay, so that is 3 is D. Crystals of iodine produce purple vapor when gently heated. So this is I2. Okay, so these are little molecules. You know, if it's a solid, that means there's some intermolecular forces there between the molecules. Now those particular ones, because well, these are dispersion forces, because these are non-polar, so they're not hydrogen bonds or polar bonds. Okay, so they must be dispersion, so those two. What's happening going from a solid to a gas? That's sublimation. That's enough to get us to D, but we could also say that it's definitely, when it changes from a solid to a gas, we're definitely increasing in the energy in the system. So we're going to say 4D. Okay. Phosphanides are a group of chemicals. Right, so what's their shape? Well, let's just draw P as a central bond and tell me if something jumps out here. Okay, so we've got H, H, and electron pairs here, right? Does that look like water? Okay. Now, like this is tetrahedral, but we don't include that shape when we're just looking at the actual atoms themselves. So that's why we say water is a bent molecule, V-shaped. This has got the same shape. So it's bent. How many lone pairs? There are 2 lone pairs. Bonded electron pairs 2, so that must be 5 is B. Right. One second. All right, so if we've got a graph like this, we could say that that's T and that's V. What's the relationship between pressure and temperature as the volume goes, volume and temperature. As the temperature goes up, volume goes up. So we can say that T is some constant with V. Apologies. And we could then say T over V to T1 over V1 V1. So what do we know here? We know that the volume, should have given myself more room here. So what is temperature 2 we're trying to find out? We know the volume doubles. And temperature 1 is 20. So, but remember this is in Kelvin, so plus 273. That gives us 293 Kelvin. And this is just the volume, we'll say that's 1, so it doubles to there. What's T2 going to be? Well, T2 is double 293. 293 times 2, 586. However, that's in Kelvin. Now, if you look over here, these answers are mostly in Celsius. So to get our answer in Celsius, we've got to take 273 off. The old hit the calculator trick. 586 minus 273. Which is 313 degrees Celsius, which gives us, let's see, an exothermic chemical reaction proceeds by 2 stages. Right, so the activation energy is 50 kilojoules, so that's the first peak. So that goes to here, but you can see we can eliminate these two just because these are only 1 stage reactants. So we're looking for 2 peaks, which are these two. So which one has 50 kilojoules in the first peak? That would be that one. Now, just to double check, we know that the overall change is 100 in negative 100, so that goes from here down to here. That's delta H is negative 100. This is not far enough, so there's 2 reasons why we pick C here for this. Right, based on the general trends in electronegativity, they're arranged in the periodic table. Which elements would you be expected to have? Right, so if we have a look at, that's right, I looked at this before, and so here's aluminium. They want you to compare zinc, carbon, and beryllium. Now, the general trend is up and to the right. So you would expect these two to be contenders here, right? Because they're diagonally closest. But it turns out that beryllium is actually very close to it. Like if you look at something called the Pauling scale. Now, so beryllium has got 1.61 on the Pauling scale, but it turns out zinc is 1.65. Carbon is way off. It's way more electronegative. Now, I really, the answer in this test was beryllium, but I think that's not really asking us. They're asking for trends in the periodic table. So to me, you should be looking diagonally which one's closest, but also which one has a similar property. So these are both metals, which the metals because of the sea of electrons. This doesn't have a sea of electrons because it's more electronegative. So this excludes carbon, comparing it to zinc. So my answer is this. Now it turns out zinc and beryllium are both the same distance away, 165 versus 161, from aluminium's beryllium was 157 or something. So it was 0.04 distance away difference between zinc and beryllium. So in that case, I feel like I need to pay both zinc and beryllium as possible answers. Okay, but I think zinc is the better answer. All right, here we're asked to. They give us an extraction method for getting gold out of poor ores. Okay, so they mix cyanide with the gold and it dissolves. But so they're asking us here, what's the increase in oxidation state? So we've got to find out what the oxidation state is. That's, as its elemental, a 0. But what is the change? Well, for this you need to know the value of the cyanide ion, which is Cn minus 1. So we compare this, right now there's 2 of these. So minus 1 times 2 makes this a negative 2. Now the overall, because it's Na, that's a plus 1. This has to be a negative 1. So gold goes towards a plus 1. So if gold is plus 1, that leaves a negative 1 as the overall charge for its, and then that would make its oxidation state. So it's increased from 0 to 1, which makes it B. Ammonium cyanate is classified as an inorganic salt. So here you need to know what ammonium is. NH4 something cyanate. You're not expected to know that, but we're going to figure out what it is because we're told with heat decomposes into CONH right with that formula. So remember, all the atoms you start with have to be the atoms you finish with. So we're missing C and O here. So it definitely has a C and an O, so it can't be A. But which one is it of these? So it's kind of like a trial and error. Let's just try C and O. So does it balance? C 1, C is a 1, N is 2. So there's 2 here, and 4H, 2 times 2 times that. Hold on, let me just check something. Okay, apologies, I'm just noticing now that this paper has an error. Should be NH2. So I guess I've got to scratch that question. Sorry for that. This is a bought paper. I sometimes trust a little bit too much. Right, okay, so we've got, this is nice, they've given you the solubility table. They've said, this is question 11, they've said, we've said that there's a river water has a sample of different ions in it. Okay, which compound would precipitate out upon addition of calcium hydroxide? So you're adding calcium and hydroxide ions. So let's have a look at what ions we've got here. Now, I mean, to me, it jumps out carbonates. You could just test them. Is calcium carbonate so you can check here, where are the carbonates? Carbonates are generally not soluble, except for group 1. And so calcium is not a group 1. Is not, so that means it's insoluble. So that's definitely an answer. Let's check the rest. Sodium hydroxide is soluble. That can't be it. Magnesium chloride. Chlorides are not soluble. You can check the table above. Okay. Magnesium hydrogen carbonate. Now, it is true that magnesium and hydrogen carbonates, that's not a group 1. So technically that would be a precipitate as well. However, it does say upon addition of calcium, you could argue that this is already a solid. But what have I done? I think I'm going to pay that as well, just because I think the idea is to test the solubility rules. I think this little nuance here is a bit wordy. So let's just pay both of those. All right. Bauxite was all contained 18% of mass of aluminium. So what percentage of the mass of the ore is due to aluminium? Well, all right, so if we're going to say 18% of X equals Y, so that's the ore. And so this is going to be the Al2O3. So Al2O3. So let's find out what percentage of aluminium makes up aluminium oxide. So if you look at your periodic table, 26.98, so molar mass Al2O3 is 2 times 26.98 plus 3 times 16. So that is 101.96 grams per mole, and 2 times equals, so the aluminium percentage there equals 20. What did I say? 53.96 over 101. So close to 50%. What is it? 52.9%. So what we want it's about half of that 18% is the mass of aluminium. Half of 18, just a bit more, is 9, so that makes it B. 4 syringes labeled as such. Okay, so which one has the highest mass of gas? All right, so what we need to do is we need to first, what is the gas here? Now, I think the trick here was recognizing that fluorine is F2. So gases of all at the same temperature and volume have the same number of moles and pressure, right? So what is the gas here? So that means it's 2 times 19. The molar mass is 38 grams per mole. Neon is 20.18. Hydrogen chloride. So chlorine is 35 plus the 1, 36.46 grams per mole. And argon, I'm just looking at the periodic table, so 39.95. So it's not really a competition between these two. It's very close between here. Now, the one difference is temperature. So how do we compare? Like this is at a lower temperature, so we should have more moles of this in a given volume than this one. So because this is going to be fairly close between here. So what formula do we use? Well, let's use PV equals nRT. nRT. RT. All right. So let's rearrange that. So N, because we're concerned with the number of moles, equals PV over RT. Okay, so let's do the fluorine first. F2. Pressure. Now, I mean, you can just put constants in for all of these if you just want to know which is more. And if you want to know the actual amount, you're going to have to put the values in. I'll do it the long way. Pressure times, now what was it? 25 mils. Is in liters, 0.25. 8.31 times temperature in Kelvin. So the fluorine was at 273 Kelvin. Okay, 0.011 moles. Okay, and so now we can calculate the mass. Mass equals moles times molar mass. 0.0. Sorry, I think we've got another 0 here. 0.0011. 0011 times 38 is the molar mass. 0.0418 grams. Okay, now we'll try the argon. Again, I'm running out of space here. So let's just put that in 100 times same volume, 0.25. But different temperature. Now this is at 25 degrees, so that's 298. Okay, 0.01 moles. And when I do this, I'm keeping my calculator answer in there, even though I am rounding, but so that way I'm not rounding in my calculation, just in case it's close enough to matter. And again, mass equals 0.001 times 39.95. and that is 0.0403. So it is very close. Gosh, I think this is 1.8 here, isn't it? So technically, the fluorine, is slightly heavier, which is that 13 is W. Yeah. Iodine trichloride. Alright, so this is, we've got two equations showing the energy. This is Hess's law calculations. We've got, now the question was though, according to this, what's the best estimate of enthalpy of formation of this solid, which is that. So how do we get to that? We know this step is exothermic, okay, but overall, now we only need one of these, which means we need half as much here, and we can half that whole equation, make it +7. Pardon me. So -88 + 7 is B, -81. 15. All right, what to do here? Well, we've got these different molecules, and we've got a mass here that they're so they've an unknown compound, but they can determine the mass composition of the different elements in it. So this is the percentage composition. Massive element in sample analyzed. Sometimes it's a position. Here they're giving us the grams, which, if it's a percentage, you just pretend it's in grams anyway. So this is okay. So let's just work with this in grams, which helps us. So now we just divide this step by the molar mass of each of these. So that's 12.01, 1.1, 14.01, 16. So if we divide, this will give us a number of moles for each of that. Oh, come on, calculator. This calculator's done a few rounds, I'd say. Okay, so 0.05 moles, 10 divided 0.1, it's just 0.1, 0.28. To 0.48, 0.3. Now what you can do, you want to find the ratio between these different elements. That will give us our molecular formula. Now, so what you can do, particularly if you don't know the molecular formula, you would start by dividing by the smallest ratio of moles. So you get the divide by 0.02, and that would be 1, and that would be 1.5, and that would be 5. Okay, so and then you would get whole number ratios. That would give you the right ratio of numbers, right? The molar ratio in the formula. But a quicker way here is we can just move the decimal place 2 to the right. Oh, so that's 03. Apologies. Okay, so we get 3, 2, 10, 5, and so that is glutamine, which is B. Analytical chemist added concentrated nitric acid to completely dissolve a 15.5 gram silver coin. Okay, so something you want to look out for here is, so we've got silver nitrate in solution. And then they're also talking about sodium chloride. This is one of those precipitates that you, what happens when you mix these together? You get silver chloride. So this is a white precipitate. So a lot of these questions in this test are percentage composition, type of questions, and quantitative chemistry questions from the first module. So you really have to know that module well. So let's have a look. So this dry precipitate, it's not silver, it's AgCl. So from the so some percentage of that, according to this formula, is going to be silver. So you get your periodic table. Is silver 107.9 plus chlorine 35.45. And what is the percentage of silver? Would be that mass again. (107.9) divided by 107.9 plus. So that's 75.2% of that precipitate is silver. So from the data provided, so remember originally here, this 15.5 grams only produced, so it must have been some other metal in that coin. So they're trying to test for the purity of the silver. So to get the total mass, percentage mass of the silver, we need 75% of this percentage of the original coin. So 12.4 over 15.5. Let's try that. 12.4 divided by, come on, 12.4 divided by 15.5. So that's 80%. So what's 75.2% of 80%? Is 60% or 0.6. Yeah. Is C. Household bleach contains sodium hypochlorite. All right. Well, okay, there's a bit of a, it's getting more difficult here. Unnecessarily difficult, but it's really, these papers are, they're really trying to find or distinguish the very, very top students. Okay, so that you got to expect there to be a lot of hard questions. So they start off and they get the sample of the bleach and then they dilute it 5 times. Then 25 mils of this produces our gas. So if we can calculate the moles of gas, then we can work back, and because there's a 1-to-1 relationship here between the sodium, what was it, hypochlorite, and the oxygen. Okay, so that's we should be able to do that. So that's a PV equals nRT question. So again, we're trying to find moles, PV over RT. What's the pressure? 100. What's the volume? Remember in liters. 0.175. 8.31 times temperature in Kelvin, 298. Zero point 0.00706 7 moles. All right, so there's a 1-to-1 relationship here between these two. So this represents the number of moles of hypochlorite in the diluted solution. So here they want to know the concentration. So the concentration is 0.00707, let's say, moles divided by 0.025 liters, because these units are all moles per liter, right? So 0.707 divided by 0.2828 moles per liter. Don't fall for that one. Why not? Because it's been diluted 5 times. So we have to times this by 5. 1.14. Right, so there's a famous graph that has first ionization energies. Hang on, what are the features? 4 features. The existence of subshells in the quantum mechanical model provides an explanation. Mainly these features. Hang on. The answer here is saying D, this overall trend. I disagree with this. These dips are lower than you'd expect, which this is S and P and the other P as it fills up, right? So these dips here are what show the it's not Z, and how are you meant to know? Oh, crap. Okay. Okay, I'm scratching this question. Apologies, I just saw that and thought they'd be asking the obvious features there. Yeah, okay, sorry. So let's move on. What is the maximum EMF, so the voltage that you'd get from a voltaic cell? Well, this is a little bit trickier than a normal one because we're using graphite, and so we're interested in the reduction or oxidation of copper, or or the permanganate. So what you got to look at is you find your where is it? Okay, so we've got our reductions. Here's the permanganate one. So these are all in reduction form. Here's the copper. Now, one of these has to flip around, but the other rule is that they have to be, the overall voltage has to be positive. So which one is going to flip? Has to be this. So the copper is going to change to negative 0.34. So negative 0.34, and then 1.51. 20. So here we go, B. 19 is B. Alright, chromium's name, blah, 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 an example chromium, blah, blah, blah. So here we've got chromium, and it's in a, so this is Cr. Now we know O oxygen's 2 minus, and there's 3 of them. So this has to be 3 plus for you to have Cr2O3, right? So we're interested in the chromium ion. And here they're asking about the electron configuration in regards to subshells and orbitals. So the trick here straight away is chromium and copper are the exceptions to the subshell system. Okay, so normally when you're filling these up, you'd start with the 4s, right? And then so you also firstly here have to find chromium, which is, where is it here, 24. So normally it has 24 as an atom electrons. Here it's going to have, it's lost 3 electrons because it's a +3 ion. So we're looking to allocate 21. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is up to argon. And so we've got 19, 20, 3 extra to allocate. Now normally you'd allocate it to, okay, there's a bit of another double check here, which is a bit, right, so I'll just go over it. So given, if there were 24 electrons, the way you allocate it is you would fill up, you put the 1 electron here and the next one here. So I mean 24, so above 18, so that's 6 extra. So 1, 2, 3, 4, 5, 6. That would be chromium. Okay, as opposed to other elements where you'd fill this up first. Sorry. All right. So this is other, chromium and copper. You just put 1 in the 4s and then fill up the rest, right? However, they want you to take 3 electrons off. Now you would think that you should take off these 3 because they were the last 3 that you put on. But that's not how it works either. They want you to take off the 4s first, and then the other one here. So that would mean that this is the correct answer. Now we went over the exceptions in class. And I think this is a bit rough. To me, if you did this one, that shows me that you know the exception rule. So you've been able to demonstrate that you know the exception, and then you've taken off 3 from here. All right, so I think it's fair to pay both of those. In this case, for my class, this is, I got to say, pretty, yeah. So for next time, I think that, to me, if you can demonstrate you knew the exception, but in future cases, just when you're taking off electrons, start with the 4s first. All right. So, I mean, yeah, look, a very tricky test, but some good work there. So I'll see you in the next section.